our MCU portfolio, specifically with a bit of a deep dive onto our new PSOC Edge family, which is focused on AI at the edge. And I really interesting conversation there with Renesas prior on that topic, and absolutely seeing, customer interest, but also, developers. I like what Max said there in terms of the number of developers that are really ready to take this on. And like Renesas, we work to make that easier for developers to adopt these machine learning solutions at the edge. And then lastly, I'm going to talk about our cooperation with RT Thread, and where you can find support across our products with RT Thread. Okay, so Infineon at a glance, there's two driving factors behind Infineon. One is around decarbonization, and that is primarily around power delivery, power supplies, power generation. So how do we do this in a more efficient manner and work towards decarbonization and electrification? And then the other driving factor around Infineon being digitalization. And I'm going to primarily talk about the second, but I think it's well understood that microcontrollers have a fit in a wide range of applications, from power supplies to connected, smart, intelligent IoT devices as well. Infineon is a global leader in power systems and IoT. So number one in automotive, number one in power, number 5 in microcontrollers overall, and for IoT, leadership position also in connectivity with our Wi-Fi, Bluetooth, and combo connectivity devices. At a high level, again, we focus on energy, mobility, and IoT, and you can see, from a company perspective, how this splits out. About 58,000 employees globally, spread across, pretty much every region. We are represented with 17 manufacturing locations, which, of course, over the last few years has become more and more important for the customer base, being able to look towards risk reduction in the supply chain, and optimizations around supply chain, as we just exited last year, a couple of very painful years of allocation in the industry. So we continue to expand our manufacturing sites and, of course, invest in front end and meaning wafer fabs and back end facilities to reduce supply chain risk.
Stephen, do you want to put your presentation into presentation mode?
I thought I was in presentation mode. Are you? Let me try that again.
We're just seeing the slides.
Are you seeing how about now? Do you see Infineon at a glance slide?
Yeah, we see the Infineon at a glance, but we're seeing the whole user interface with the other slides at the left-hand side.
All right, let me try it like this then. Is that any better?
No. Yes, that's the one.
Okay, all right. Don't know what happened there, but great. Okay.
Thank you.
Yeah, thank you. So now let me continue, go a little bit deeper in terms of microcontrollers and how we fit into Infineon and frankly speaking, many of the problems that our customers are trying to solve. So if we start on the left, there's end products or end devices out there, and then where we fit from an Infineon perspective in terms of the capabilities, whether that be the compute capability that we're going to talk about in more depth today with our MCU portfolio, the connect capability, which I talked about with wired and wireless connectivity, sensing. And I really enjoyed that discussion earlier on microphones as well. And I think we see a very similar trend in the market that there's really a lot that we can learn from audio signals, even some of those audio signals at frequencies that human ears can't detect, but are out there. I actually just read an interesting article a couple of weeks ago that Max, you're talking about the human ear in a manufacturing environment. I read an article that the human ear can detect the difference between pouring hot water and cold water, which of course I had to go and try that, and it was absolutely true. Now I may have been biased in my one-person study, but there's a lot of things from audio signals, of course, that we can detect. So in sensing, we often talk about audio, but we also talk about radar and time of flight and CO2. And then I think you mentioned also vision systems earlier with more traditional cameras. And then, of course, actuate through power. But at the heart of all this, of course, is the software and the ecosystem that our microcontrollers live in. And we're really excited that our key thread is part of that ecosystem for us. This, of course, really helps our customers develop quicker, reuse their software from project to project in a less obtrusive way. And we know there's value in that, and we're happy to be here today presenting. But I think really happy that we're able to work with our key thread to make that happen for the broader customer base as well. Now, within that, I'm going to go into a little bit more depth in a few slides here in terms of the broader set of capabilities that we deliver on the device level, and then also from a PC and tooling perspective to support our customers as well. And then, of course, I am going to talk a lot about Edge AI today. It doesn't mean that these devices aren't often connected and don't benefit from being connected. It just means they don't need to always go to the cloud to send and let's say, determine what is happening on the edge. All right, so the Infineon MCU portfolio, we target a wide range of applications with our portfolio. If we look at consumer applications, this ranges from home automation, human machine interfaces, wearable devices, a range of battery powered consumer applications that are really concerned about low power capability, and increasingly more autonomous capability as well. And then portable medical devices. Kind of the capabilities that we bring, and we largely target this with our PSOC family today. We have a strong capability around HMI, which is touch, proximity, gesture, inductive sensing, liquid level sensing. So a lot of sensing capability built into our PSOC microcontrollers. Ultra low power for battery powered applications, and then a lot of flexibility and customization available in the MCUs themselves. When we look at industrial, here we have home appliances is a main focus area for us, and there we have PSOC and XMC microcontrollers going into home appliances with serving a range of functions from motor control to main card to HMI and sensing. Then we have power conversion and transportation, primarily today service with our XMC products, and factory and building automation with XMC and FM and RX, which is coming from the automotive side of Infineon. So very transportation based kind of products with functional safety built in. Going forward, you'll see 3 lines of products from Infineon from an investment perspective. PSOC Edge, which I'm going to talk about in depth today. PSOC Control, more focused on motor and power applications, and PSOC Connect, so connected MCUs. When we talk about AI at the edge, of course, there are lots of benefits of that in terms of low latency and more real-time response of these systems. Of course, higher power efficiency, so reduced power consumption, improved security and data privacy, and then of course reduce system cost. And that's not just the bill of materials cost, that's the cost of ownership of having a connected device, and that may be otherwise needing to stream data to the cloud constantly. So you see, we're seeing customers see a significant advantage to moving more intelligence to the edge. And I'm excited to say that Infineon is really enabling that from a hardware and from a software and from a tool chain perspective. I'm going to talk a little bit about kind of the types of functions that we are enabling on edge devices. And you can see here, if we look at this as a kind of classify the types of things that we see developers working to enable through machine learning into kind of general machine management, audio, voice, and language, and then and vision. And traditionally, PSOC 6 here is a Cortex M4 class MCU. So traditionally, you can do these things on the bottom here with a kind of, I'll call it a brute force approach on a M4, M33 class MCU. Like anomaly detection. The previous discussion there was around an IMU detecting a change in the vibration signature, for example. Enabling predictive maintenance as things perhaps wear out over time. Those are very capable, types of models in kind of a classic ML perspective that can run on M33, M4 class parts, single microphone, keyword spotting, those kind of things. But there's a much more richer set of capability, of course, as you go up in performance. And I'm just going to jump right to this top row here, which traditionally has been, relegated to Cortex A class processors. And that's because of either the brute force performance of a high performance apps processor, or it's because of, that's where we first started to see neural net coprocessors being added to the silicon. With PSOC Edge, we've added actually 2 NPUs. I'm going to get to that in a bit here, but we can do then enable the most advanced kind of machine management capabilities. We can enable full beamforming for far field voice support, enable noise suppression, enable natural language processing on the device. And then some pretty advanced acoustic event detection as well. So when it comes to audio, this clearly is a place where ML is really starting to excel, well above and beyond what is being done with traditional DSPs, whether those be for DSPs, or I know there's some use cases around DSPs for ML. But what we're seeing is that dedicated neural net processors can really advance the capabilities around the audio pipeline, and then recognizing what that audio event is, whether that's a word or a sound. And then, of course, if we look at the vision applications, things like, of course, face recognition, position detection, object tracking. So lots of capabilities now enabled on an MCU that more traditionally have only been supported on MPUs. So if we look at PSOC Edge, a little deeper dive, Cortex M55 plus the Helium DSP extensions in the high performance domain as the main scalar and DSP math. And then we have a low power domain, which has a Cortex M33 and its own local RRAM non-volatile memory support as well. So rich memory interfaces, so lots of memory on chip for the applications and your models, but also the ability to expand the memory in a very cost-effective way. Robust security, so these devices target what we call, what the industry calls PSA level 4. So this is a specification that Infineon worked closely with the PSA organization to develop. It was announced last April. And we believe that PSOC Edge will be the first PSA level 4 certified product family in the market. This is becoming more and more important at the edge, and we're seeing customers who, everybody always wants to protect their code. There's no doubt about that. Like that's the investment largely that developers make is writing their code. But it's becoming a very different game when that code is an ML model, not just because of the time and effort creating that model during the development phase, but because of all of the data that is behind that model. Companies spend a lot of money either collecting data to create a robust model, or they license data. They spend money to license data to create that robust model. And that needs to be protected. And I think we're seeing a lot more interest in protection of what's on the device locally, because it's more and more increasingly valuable IP on those devices. Of course, as we go and enable more capability at the edge, there's also a user data privacy concern that comes up, and having a high security on these devices is important. Then I mentioned about machine learning. We fundamentally believe that neural nets are the future here. Yep, classic ML will have a place, and doing this brute force on a CPU will continue to have a place. But when you start to combine the capability of large data sets with neural nets, with dedicated hardware to process those, you really start to see the power of ML be unleashed on these edge microcontrollers. We also then offer an end-to-end development solution. Infineon acquired a company called Imagimob about a year ago. I'm going to talk a bit more about what that means. It's really a really flexible way, an intuitive way for developers to engage in creating a machine learning model for their device. The other thing that I would say here is that a few years ago, there was a lot of, I'll say, maybe reluctance at developers to take on the creation of machine learning models, thinking they needed data scientists. And I would make the argument when we get to the Imagimob content here that actually this is easier than what many customers do today from an application development perspective. We also, of course, enable our products through Modus Toolbox and a variety of third-party ecosystem tool chains as well. Okay, so I'm going to start a little bit with the hardware here. So the E84 is the highest end device that we announced so far. So I'll walk through this here. Let me see if I can get my present. No, I can't. Okay, I don't know if you can see the mouse, but I'm starting in the upper left of the picture here. So high performance compute domain, which is M55 plus the Ethos U55 plus the Helium DSP extensions, all running up to 400 megahertz. 32K of iCache and Dcache plus 256K of TCM, both instruction and data. So really high performance, enabling direct memory access for a range of applications, including model operation. Up to 5 megabytes of shared, we call SOC-MEM or system RAM, and then an additional 512 bytes of non-volatile RRAM. And then in the low power domain, we have another megabyte of SRAM, which is connected to our M33 and another neural net processor we call NN Lite, which is a lightweight neural net processor for absolute low power ambient sensing applications. So here, this is a very powerful pairing. And what I like about this pairing, as well as the pairing of the M55 plus the U55, is that if developers can program Cortex-M, the tools handle the rest. So it's not, I'm going to, in my low power domain, for example, it's not, I'm going to do part of my application in the M33, then I need to go and talk to the DSP team to program the DSP to detect the to detect the audio signal or perform some filtering on the signal chain. Again, we solve a lot of that complexity in the tool chain, so the customer can or the developer can focus on developing for their application. From a HMI perspective, the ability to do local voice, support cloud voice, keyword spotting, wake word detection, vision solutions I mentioned earlier, and then what we call friction-free interface and safety. And there was a discussion earlier about robotics. Doesn't necessarily need to be a big robotic arm in a factory. I think we're going to start to see, humanoid or other robots more and more in our homes and in our daily environments. I have a set of robots that cruise around my neighborhood delivering food from restaurants. These things need to be environmentally aware about what or who is around them, and be prepared to go into safety mode and avoid injury to those around. So a lot of safety functions coming in through ML and sensor integration. Then of course we have a 2.5D GPU here as well, supported through MIPI DSI interface. All right, lots of serial peripherals, and then of course the secured enclave supporting up to 25 Jill points, which is how do I say it? There's security experts out there, you'll know that this Jill score rating. But for those that are not experts, PSA does a really nice way to convert that to both capability, but also various regulations around security around the world. And what that kind of converts to is a PSA level 4 certification level. Okay, now if I come back to the machine learning capabilities here, I mentioned the ImagineMob tool chain. This is really a developer-friendly tool chain that is end-to-end from I don't have any data, I need to get started. So it will support data collection, and I'm going to talk more about how we enable that with some new hardware as well. But can go from data collection all the way through model output, to putting out or deploying a pruned and optimized model onto a device. However, it's really a meet the developer where you are. So if you already have data and you just want to start with your data set and start labeling that data in the tool, that's great too. You already have a labeled data set and you want to work on your model, that's fine. You already have your model, no problem. You've developed your model in TF-Lite, for example. You port that in, and then these tools will finish it off and get it onto the target device. So a very flexible design flow for developers, kind of meet the developer where they are. And I think another nice aspect of this is, the output of this is C code. So again, we're not, let's say, trying to build barriers around how you develop your application. It's the developer's data. It remains with the developer, and then the output of that is a model in C code, and that is also very transparent in terms of the output of the tool chain. That resides within Modus Toolbox, which is our broader development ecosystem for our customers, and then gets it onto the target device. Could be any PSOC device, but here we're talking about PSOC Edge, of course. I think I'm going to skip this one in the interest of time. I already spoken quite a bit about security, of course. And yeah, let's skip that one. So a little bit more detail. The hardware eval kits are available now. So there's a really feature-rich and header-rich baseboard with lots of sensors and connectivity options. And then we have a SOM, which is our PSOC Edge device with ample external memory support, as well as a Wi-Fi Bluetooth combo device from Infineon. Lots of, I'll say, enablement software here and tool support you can see on the left, as well as full development workflow. But then, of course, a lot of more specific application example code as well in terms of voice and audio middleware. So we are shipping these devices now to lead customers. You can find out more information at infineon.com/PSOC Edge. And if you are interested, you can send an email to that email address as well. All right. In the context of our key thread, I want to talk about some other devices as well, which is the XMC 7000 family. So this is up to a dual core M7 platform with megabytes of internally supported NVM. This is also supported through RT Thread. Very capable, more focused on industrial applications, full 5-volt support, extended temperature range, and also, again, supporting SIL 2 applications from a safety perspective. I think I won't go through all the details here. It's a fairly well enabled. I think you can see that from the block diagram in terms of timers and ADCs and other peripherals, and then of course as well as performance for this class of processors, and then supporting industrial protocols such as Profinet, Ethernet, CC-Link, and CAN Open. This is the dual core version, so the 7200. And again, this is full production. Kits are available today for developers to get started on. I'm going to skip that. I want to talk about this new kit, which is a PSOC 6 kit. And this is what I was talking about. I mentioned briefly earlier in terms of data collection. So here's a great kit, and I think there's actually, it's interesting, there's a lot of projects start like this, which is, let's develop a small kit and deploy it and start to collect data. And that's really what the intent of this kit is to enable people to begin this AI at the edge journey with this tiny kit that is sensor rich. We've made it easy to use, both from a hardware and from a software perspective. Easy to create the models. We also deploy to this kit and other kits what we call ready models, so already created models from Infineon. A range of those, like siren, like baby cry, like dog bark, kind of the classic, let's say, audio event detections that you may be looking for. So a range of ready models that are already done, and by the way, built with our own ImagineMob tool suite. So this kit can run those models, or it can be used to collect data to create your own model through the ImagineMob tool suite. So this is going to be launched this month, actually, and we're looking forward to supporting this as well in the RT Thread ecosystem. Last, I'm going to talk about new devices we have around proximity sensing and CapSense. So as I think, I hope you're aware, the CapSense capability embedded into our PSOC microcontrollers is world-class, and we continue to invest and expand that technology to do proximity, to do inductive sensing, so sensing through metal surfaces, as well as gesture and other functions. So really robust, low-power technology from a sensing capability integrated into our PSOC microcontrollers. I'm going to skip that, and then I'm going to move on in terms of focus more a little bit on RT Thread. So, of course, increased MCU performance paired with more capable software is really driving this transition from MPUs to MCUs. And I hope you see the possibilities here now really becoming coming to fruition in the market when we look at a product like PSOC Edge. On the one hand, the performance is there, not just because it has a 400 megahertz CPU, for example, not just because it supports DSP functions, but in addition to those things, it has the NPU that can really accelerate machine learning model execution or do more on the application on those devices. But also those devices now start to have the kind of things that customers traditionally had valued in MPUs, like rich external memory expansion, high-speed peripherals, GPUs. So the things that had previously been kind of relegated to high cost, high performance, power hungry MPUs, are now clearly starting to show up in MCU portfolios. Here, of course, I'm here to talk about PSOC Edge, but I think you can acknowledge this is an industry trend. And what that then opens up an opportunity for is for software ecosystems that are easy to use, easy to engage with, and well supported to migrate applications from these MPUs to MCUs, moving from Linux to RTOS. And we clearly see that, of course, as not just an opportunity for us, but for developers as well, to reduce system costs, reduce system power, simplify designs, and add more capability at the edge as a result of that in terms of real-time performance improvements. Okay, so Infineon has a pretty significant engagement with RT Thread in terms of cooperation on content. So PSOC 6 integration into RT Thread Studio. We've released the PSOC 62 plus our 43012, which is a Wi-Fi Bluetooth combo device. And then also we have a radar shield for that, which all of those things are fully released. We're working on getting that AI, the PSOC 6 AI kit enabled then, which to launch in June. And as we go to market with PSOC Edge, of course, we'll support that in RT Thread as well. And we're working with the team to make that happen. So really embracing the RT Thread ecosystem and looking forward to strengthening that cooperation as we go forward and continue to release new microcontrollers. Okay, I think that is it. So that's my last slide. I will stop there. And again, looking forward to more cooperation with RT Thread and the ecosystem surrounding that.
Well, thanks so much, Stephen. I must admit, I was just thinking or making sure that some of the maybe younger attendees, I would like them to be sure to understand that the PSOC devices, in addition to the processors, they also have programmable analog and programmable digital functionality. I used to have a friend who worked at, well, it was taken over by Infineon, and we'd be chatting on a Friday about some hobby project, like creating a microphone array, like on the Alexa, that when you talked, it could identify the direction and from time of flight. And by Monday morning, he'd got one working that he'd thrown together at home using a PSOC device. It's amazing technology.
Yep, totally agree. We're still
you,
excited about it. It's been around, like you said, a long time, but really enables innovation that we couldn't have predicted, frankly. So builds in a lot of flexibility and capability for customers to be creative and to innovate around their products by using the PSOC microcontrollers.
we've got a question here in the chat. He'd like to ask a question: since low power devices are a thing in embedded systems and IoT devices, is it possible to combine low power devices with ML and AL capabilities?
I love this question. So first of all, I think the answer is yes. And I'm going to give some really a specific example here, but two examples. So first of all, I didn't show kind of, for example, the voice pipeline on PSOC Edge. So the way this works is today, you may know, actually the problem with voice today is those devices where you're using voice control, most of them are cloud connected, the overwhelming majority of them, but they're also either plugged in all the time, so they're wall powered, or you charge them at least, but sometimes more than once a day. So of course, by wall powered, I mean your smart speakers, and by charge them once a day at least, I mean your phone or maybe your watch. And then of course, there's this other class, which is your car. So they're powered by generally a gasoline engine, or they're plugged in overnight. So that's the problem with voice. It's not going far because to always be listening historically takes a lot of power. On these microcontrollers, so what we do with the M33 domain I showed on PSOC Edge paired with that NN Lite is an always-on audio detection capability using ML. So actually here ML lowers the power of the system because it can just be this little wait, or wait and wait. And then I can process, do I think that's a wake word? And if I think it's a wake word, then I bring up the high performance domain, process it, determine was it really a wake word, then yes, let's continue. If no, shut everything back down. So in that specific case, ML really reduces the power of the system. Now, I'm going to give another example here, which is a radar example where we have our radar system doing radar sensor connected to a PSOC 6 MCU doing occupant detection using this ML model. Okay, we move that to PSOC Edge and run that on a U55. It's 1,000x the improvement in terms of performance. Okay, now what does that mean in terms of the system? It means two things. Well, it means many things, but it could mean one of two things. It can mean it can happen a lot faster, so those devices actually consume less power. Or instead of just doing occupant detection, it can start to do a lot more features with that radar sensor in terms of knowing maybe who's in the room, what position they're in the room, other let's say capabilities around radar. So actually moving ML to the edge on MCUs, for me, it actually reduces power consumption of the system, and that's what we're seeing in the examples that I just gave, but frankly, in the development of the PSOC Edge platform.
No, thanks. We've got another question here. If we
The answer
use,
is yes.
Yeah.
Sorry, yeah. I think you're going to read it. If you use Imagimob, code will be optimized features for PSOC, such as helium and ethos. Absolutely. So the answer is yes. It's a little more complex than that because there's interactions between the Imagimob tool suite and the Modus Toolbox tool suite. But in short, the answer is yep. That's why well, part of why we've acquired Imagimob is to really bring that end-to-end development, but do that in a way that it's optimized for our products that we're bringing to market.
Mm-hmm. Well, the other thing about voice control, one of the reasons why you've got something like the Alexa is connected to the internet is that people can say, how far is it to the moon? What's the temperature in Alaska? All that. But if you're trying to put voice control on a coffee machine, people don't usually want to engage it in the conversation. They're just going to say, give me a cup of coffee, and it'll say, do you want cream with that? Yes, please. So it's a much more limited command set.
Yeah, and I will say though that so you're absolutely right, and that's where this is going, is that the ML capability, and I'm going to bridge this to a lot of people asking about Gen AI, for example, at the edge nowadays. The ML capability will look different. So it'll be, by different meaning, it will be more application focused. So I love your coffee maker example, but I'll give a little more complex one, which is a thermostat. Okay. Turns out in English, I could probably name 100 ways to turn the temperature up. Okay. Right. Turn it up, make it warmer, set it to 76, move it to 76. Then I can use Celsius, right? There's probably 100 ways. Okay. And then it's turn it down. So there's lots of permutations on a thermostat, how to control that with voice, and being able to do that with natural language is clearly of value. However, being able to set all of those potential commands in a methodical way really isn't, I think, let's say, realistic or comprehensive. And when you get into a situation where you're training the user how to do something, that's not machine learning, that's human learning. Okay. Right. If I have to learn how to interact with the thermostat, machine learning has failed. Okay. Yeah. Now I want to go to the next step then, which is this Gen AI and large language models, which is, again, I'm never going to ask the thermostat to write a dissertation on the US Constitution. It's not going to happen. But I will ask the thermostat, why won't this thing connect to my Wi-Fi? Right. And for it to be able to page through all the manuals, maybe even what all of the Reddit channels, whatever, in terms of why these thermostats disconnect from the Wi-Fi, and give me an intelligible answer back, that's a value. Okay. Mm-hmm. And clearly that's coming.
Well, yeah, and also the fact that all the thermostats of that type can be transmitting information up to the cloud, saying these are questions that people keep on asking.
Yep.
So your thermostat can work better because somebody else's across the world didn't. There's another question here. Is there a baseline of processing power requirements before integrating ML and AL capabilities?
I would like to.
I think that what that means is
Oh,
this.
okay. Yeah, I think I get it. And I would say
It sort
I
of
would,
depends what. Yeah, if you want
yeah,
vision, then it's a higher baseline than if you want to detect temperature fluctuations.
yeah, yeah. That's a great answer. I talked about what it mostly with PSOC Edge. You know, kind of the higher end of where MCUs are going. But clearly, a lot of the stuff like that TinyML is doing still on M0s and M23s, clearly still relevant. So fundamentally, yeah, there's a minimum set of compute performance required, but it's a pretty low bar depending on what you're trying to do or how long you have to do it.
Yeah.
Some things obviously are more time sensitive than others.
Well, there's a really good book called TinyML, and I used that and some other stuff to build a little ML model in 2K that monitored the current on a vacuum cleaner and told me when the
Yeah.
bag was full.
Yep.
That's really interesting. Thanks so much, Stephen. If anyone wants to know more, I've been given an email address that people can contact. And I'm sure, Stephen, you'd welcome questions and things
Absolutely.
offline.
Yep. Absolutely.
So I'm just so excited to see where things are going. With Infineon and the whole industry, it's mind blowing to me.
Yeah. That's an
So
exciting
thanks.
time. Yep.
Thank you so much. I'll probably see you
All
here
right.
next year.
Yep. Thank you, Matt.